All right, we talk about joint design now. Outline here, what determines joint design, weld features, type of weld joint, welding symbol, position, bevel, designing weld joints. All right. So the weld, a permanent union between material caused by heat or pressure. So we got butt weld, and also we got fillet weld here, right? So in fillet weld, we have throat thickness. So there is two types of throat thickness. We have actual throat and also design throat thickness. Yeah. And then we have leg length, horizontal and vertical leg length. All right, this is 3.1 staff. Yeah. All right, here, when we talk about joint preparations, square edge closed bar. Square edge closed bar or square edge open bar, this apply for material less than 3 mm normally. Very thin material, thin plate. Where very thin plate, when we weld, if we have electrode from the top, if we weld, penetration can achieve to the bottom of the plate. There's no problem at all for very thin plate. Same thing goes to open square bar. Yeah. Any distortion? Normally there is no distortion. No bevel. No bevel, no distortion. Okay? When the thickness increase, maybe 10, 20, 30, 40, all right, depend on the drawing from the design. We can have single bevel, one side bevel, or maybe we can have single V, right? Both side bevel. We can have single J, or maybe we can have single U, right? Okay, if we compare single V and single U, all right, single V and single U. Single V, for the same thickness, it will give more wear volume, all right? And also there is a shrinkage, bigger shrinkage. Shrinkage bigger, yeah? Comparing to single U, you got small volumes of weld, and then you got small shrinkage, yeah? So as a result, single V got more distortion, yeah, comparing to single U, right? So this type of joint giving single V especially giving more distortion comparing to single U. All right. In single U, there is less distortion, but it has problem with solidification, crack. All right, the problem with solidification, crack. Yeah, we're going to discuss detail in topic weldability of steel. Why single U are more likely high risk in solidification cracking. Okay. All right. Then we talk about double-sided. Double-sided preparation are normally made on thicker material or when access both sides is unrestricted. So we have double bevel here and top bevel, bottom bevel, one side square, double J, top J and bottom J, another side is square. Then we have double V, all right, top and bottom V, W, top and bottom U. All right. If we are comparing single V and double V, which one is easy to weld? Which one is easy to weld? Double V or single V? Write down your answer in the chat box. Write down now your answer in chat box. Which one is more distortion? Easy to weld? Easy to weld. All right. Aswadi said double V. Ashari said single V. Result single. Easy to weld, yeah? Marwan, what's your answer? Which one? Easy to weld? Write down in chat box.
Double P, sir.
Okay, double V, easy to weld.
Yeah.
All right, the answer is double V. Why double V easy to weld? Imagine like this. Single V, the welder need to make sure that penetration produced are acceptable with a good quality penetration here. All right, because most of the time, single V in the root, normally you've got lack of root penetration, lack of root fusion, maybe it's root concavity. There's always a problem in single V when it comes to the root. There's possible few defects there, yeah? But when we're comparing to double V, so what happened here? The welder can weld few layers on the top side here, and then he come back, grind off at the bottom, grind, and then re-weld again few layers, come back on the top, maybe weld few more layers until completed, then weld again at the bottom until completed. Right. The easiest way to weld is double V, because the welder don't care about the root penetration, because he's going to grind again, remove, re-weld again. So that's why double V easy to weld. And remember, because of balance welding can be done, so there is no distortion. Yeah? Double V, we produce less distortion comparing to single V. Single V, more distortion because of you weld only from one side. So distortion take more in single V compared to double V. Yeah? And double V is more easy to weld. And remember this thing, when you qualify a welder with double V, he not qualified to weld single V because of difficulties in single V. So single V require more skill, got it? Compared to double V, right? And this is talking about included angle, angle of bevel. Angle of bevel in CSWIP normally is take from 30 degree plus 5 degree. So it can be between included angle 60 degree up to 70 degree, all right? And rule face about 1 to 3 mm. All right, in single U, roughly about 20 degree or 20, 30 degree included angle. Yeah. All right, we move on. All right, design better life expectancy, loading type, full penetration but will give better life expectancy compared to partial penetration, and compound weld will give better performance than fillet weld. All right, we're going to talk a bit about compound weld here. All right, example here. Talking about compound weld, yeah? So we have T-joint, all this talking about T-joint. This one also T-joint. This is T-joint, okay? Fillet weld, they said fillet weld when there is no bevel at all. There is no bevel. It's only fillet weld both sides. Example, maybe one side or maybe both sides, but it's only fillet here. So that's why they call it fillet weld T-joint, okay? Another example here, you can see there is a bevel. So bevel here, we say as a single bevel. When we got single bevel here, so this weldment, we call it butt weld. That's why here it says butt weld in T-joint. T-joint not necessarily got fillet only. You also got butt weld in T-joint because it's single bevel there. Okay, clear about this? All right, so how compound, the name compound come from? When there is two combination, or I can write down here, combination of two types of well. Combination of two types of well, so we call it compound well. Yeah, so that's the name compound from. Combination of two types of well. Example here, we have here, because of single bevel, we have butt well. And from outside here, we got fillet. So here, example about combination of butt well and fillet. So that's why they call it compound. All right, got it? All right, another example. We have leg joint. All this talking about leg joint, and also leg joint here. And this one, we got fillet. Here we got fillet. Maybe one side or both sides. Then another one here we got spot well here. Right there. Combination, we got fillet, and then we got spot well. Combination, then we call it compound. All right, clear about this? The meaning of compound well.
Yep.
And another example here, we have corner joint, corner, and corner. Here, we only have fillet there. It's only fillet. But now we have bevel. So they call it butt well here. And compound, when it's combined, butt well and fillet. All right? So compound well in corner joint. You may copy this if you want. All right? I have no restriction. You may take photo if you want. It's up to you guys. Yeah.
Can we record this lecture?
Yeah, if you want. Okay.
Okay.
All right, let's move to our slide discussion. What we discussed earlier about this compound, yeah? So I think everybody already very clear about what mean by compound well. All right, now in welding process, determine weld joint design. Normally in SAW, they not allow any open root run. Why? Because of problem with open root run here with SAW, we got burnt through. I always burn through, all right? So that's why they're not allowed. So either they use different process in the root, like MMA or TIG, weld few layers, root hot pass, filling pass for few layers. Then later on, they bring this pipe or plate to SAW. Well, that's combination process. Can, but cannot alone SAW weld from the root to the cap unless they have baking. You know, kind of like baking, ceramic baking, then okay. Yeah. And then they talk about closed square edge, thin wall, stainless steel dairy pipe, closed butt joint with TIG, positional welding here with SAW. Normally SAW position is PA, PB, and PC. We're going to talk later about this PA, PB, PC, all right? All right, material thickness, butt weld, generally as material get thicker, single preparation become double if there is excess, all right? Butt weld generally as material get thinner, root get close. T-joint, generally material get thicker, the vertical plate is prepared in compound weld, right? Quality, in order to have a good quality root, normally we use baking like ceramic or material that won't fuse. This normally apply in, you know, baking here, normally apply in SAW, all right? Other process like TIG, MMA, normally they're not doing any baking, yeah? But SAW, normally you must have baking if there is open root, yeah? And also sometimes there is a requirement to do the NDT, NPI or die pen, right? Especially in double V, double V. The welder will back gauge at the back and then do NPI die pen in order to make sure there is no defects present. Yeah. And then complete the weld. Excess here, if we have all fillet weld, then we have trouble here. Why? Possible there is no access. Another thing, safety reason, confined space, right? And there is many things involved for safety reason. Then better change to single bevel, the rest of the joint. We can have fillet weld and then single bevel for the rest. All right, here, the leg joint, possible there is access problem here, then change design, then we have better access to weld both sides. Yeah? And this is welding position. Example here, this is PC position. All right. Horizontal positions. Normally in this weld position, PC, the top bevel prepare 45 degree. Right, and the bottom one here, normally up to 15 degree. Yeah, so this is to avoid overspill, they call it. If this angle too much, the angle is too much, then possible overspill, they call it. Yeah, so to avoid that, then there is small bevel here. Better, 15 degrees. Okay, that is what normally in PC position. Yeah? We talk about that later about this. Yeah. Okay. All right, talking about weld volume, what is said here, U bar between 20 to 30% less weld volume than V bar. Then what a good thing about having this U is say reduce cost. In this case, reduce consumable cost, reduce stress, and also reduce distortion. That's a good thing about U. Disadvantage, additional cost, preparation, machining. That's additional cost. Yeah. Comparing of single V and double V, you said double V has less weld volume than single V. That's true. You see how big, for the same thickness, how big the bevel here. Then it consumes a large electrode, all right? I mean, consume more electrode. If we make it double V, then it will reduce the consumable cost. Yeah. And the good thing here is say reduce cost, reduce distortion, reduce stress, and high quality. Yeah. Disadvantage, access to both sides required. All right. All right, here they talk about distortion control. We have double V and asymmetrical. Asymmetrical means not the same size. If they talk about symmetrical like this, it's the same size, symmetrical. Symmetrical is the same. Asymmetrical are not the same. Like here, we got 1/3. Here we got 2/3. Okay? Talking about shrinkage, we can see here, like this one is single U, and this one is single V. We say U but has significantly less liquid matter and more even distributions of wear matter in the uppermost region than the V but. Therefore, greater shrinkage and distortion occur in V. Remember, when you have more bevel, more shrinkage, more distortion. So that's what they try to say here. Yeah? All right, level of penetration, we got full penetration and partial penetration. Partial penetration, the problems here, fatigue failure always occur, right? Fatigue failure. Gas purging pipes, normally we apply in TIG process for stainless steel normally. So we need to do gas purging in order to remove a problem with the root oxidation. right? Especially in material like stainless steel. Yeah. All right, this is important for you guys. There is a few things you need to memorize a bit. Yeah? We're talking about nozzle now. All right, there's a few questions asked. Yeah. All right, nozzle connect a pressure vessel with other components. We say type of nozzle depend on diameter, thickness, shell, diameter, thickness of nozzle. So here, like here, we have this is branch. Sometimes we call it branch, but that is nozzle. Connecting to maybe vessel, then we call it shell. Here is shell, and here is nozzle. Yeah. Shell can be from tank, vessel, big diameter pipe, or main pipe. That is, we call it shell. Yeah, connecting to nozzle. Right. Maybe it's TKY joint. All right, something like that. All right, there is a few things you need to memorize here for set on nozzle. Set on nozzle, sometimes they call it set out. Set out or set on, meaning nozzle sit on shell. So here is shell, and here is nozzle. All right? All right, remember in this one, nozzle, in this set on, nozzle is bevel. Bevel carried out on nozzle. Got it? Yeah? This is applied for set on, or another name set out. Then please highlight this one. It said easy to make groove, full of partial penetration. Single-sided welding position mean high-skill welder. Highlight this one. And also we have another problem here. It said danger of lamella tearing. So lamella tearing after weld completed. Here, and possible we got lamella tearing there, right, in the shell area. Can be difficult to UT, especially in smaller diameter, mainly used for small, less than 2-inch diameter nozzle or thick wall, large diameter. May require reinforcement. Sometimes reinforcement, we call it in project saddle, right, like a horse saddle. All right, so here in set on, remember, we have bevel carried out in the nozzle. Yeah. And then we have shell here. Okay. And that is reinforcement. This is example of reinforcement. Okay. All right. We move to set through nozzle. Another name, they call it set in. Yeah. Set through or set in. Look at here, we have nozzle set in or set through the shell. So here is nozzle. And then we got here, which is shell. Yeah. And remember, bevel carried out in shell. For set through, bevel carried out in shell, not in nozzle. Clear about this? All right, highlight this one. No danger of lamella tearing. That's a good thing about set through. He said no problem with lamella tearing. So what is it, lamella tearing? We discuss detail in topic weldability later. Maybe on the 3rd day or 4th day. Okay? Easy access to backside of the root, so full penetration easy to achieve. For nozzle with small diameter, no need reinforcement. Nozzle body need to be longer. Greater wear volume means higher distortion. Can be hard to use on small diameter, usually easy to inspect. Use on large diameter nozzle and thinner wall, small diameter vessel. All right. All right, for this one, we look a bit, we're going to check, where is it here? All right, from what we see here in this set through, there is possible fillet weld on top and also bottom. So meaning weld carried out from outside and also from inside. In this one, looks like bevel from inside and then outside is fillet. Here, all weld from outside with reinforcement. Yeah. Here we got single bevel, weld from inside and then outside reinforcement and re-weld again. Another example here, we have fillet weld here, reinforcement and then fillet weld. Here, single bevel from inside, weld from inside and also reinforcement weld from outside. Okay. This talking about reinforcement or compensation. And this one talking about the CSR or EB mean electric bolt. Normally this apply in consumable socket ring here. Normally apply in TIG process, TIG welding using this consumable socket ring. Okay? And then we have narrow gap joint, narrow gap welding height. All right. Questions? As a senior welding inspector, you are assigned to fabrication of carbon manganese pressure. Vessel main barrel thickness and dish end are 25 mm wall thickness. All nozzles set in or set out. Main waist 20 mm thickness. During fabrication and welding, your main concern are distortion control, joint design, and all other quality aspects. You have 10 questions. I will discuss a bit with this question for, is it question required specification or not required specification? Okay? Then you do it as your homework. All right, got it?
Okay.
Do it tonight if you have time, okay? All right, question 1, this one not require any spec, no spec. Question 2, again, there is no spec. You have question with you guys, yeah? 10 questions. Right. Question 3, looks like there is no spec, but you may refer to spec about this SAW welding process. Yeah, that's fine from the spec about information about SAW welding process, but it's not really required specification. Distortion, I think no spec here, not referring spec. 5. Basically, it's not really required spec, but also you may refer to spec for this welding joint preparation. Find it in joint preparation, okay? You may find in spec joint preparation, but not really referring to spec basically, but referring to spec will give you some idea, okay? 6. This one, very clear. They ask you from spec, then you must refer to spec. 7, again, this question refer to spec. 8, please put this one, PA position. Write down in your questions now. Additional. Assuming welding is in PA position, all right? If not, then difficult to discuss question and answer. Write down this PA position in your questions. All right, got it? And this is referred to spec, okay? All right, 9, inspecting units in line. All right, this is spec, refer to spec. And then 10, this one is no spec. This question not refer to spec, all right? Your handout, your books, your knowledge, okay? All right, I repeat one more time. Question 10, no spec. 9, refer spec. 8, spec. 7, spec. 6, spec. 5 not required spec, but you may refer to get some idea there. 4, no spec. 3, no spec. 2, no spec, and 1 is no spec. Okay? Look at question 1. You notice the joint preparations are not shown on engineering drawing for set in. set in, or another name is set through. Yeah, set in, set through. Which of the preparation would be suitable full penetration? So the answer about full penetration. So that is set through. So we understand this is nozzle. That is nozzle, and we have single bevel in the shell, right? So full penetration can be achieved by having the butt well, like a single bevel. Yeah. So that's where the best answer goes to A. But remember, this bevel carried out in shell. Yeah. Because that is set through or set in. All right, question number 2. You notice the joint preparation are not shown on engineering drawing or WPS. In the case of set on, or sometimes they call it set out. Yeah? Set out. So in this set out, we have square shell. They're not doing any bevel to the shell. And then it has bevel for the nozzle. All right, so that is, again, which of the following joint preparation would be the most suited? So the answer goes to C, single bevel butt joint. But remember, this is on the nozzle. Yeah, all right. Question 3. The fabricator suggests to you that it will be much more cost effective to weld up pressure vessel from the outside only. So they said outside only. Without any back gauging, the WPS show all the main barrel section and dish end barrel joint of full penetration, but welded with SAW and back gauging from inside and weld with MMA. So the procedure already clear about having two process. Yeah. Without looking at the spec also, we can see the best answer here, which is D. The reason why, because of SAW cannot be welded with open root. Yeah? So burn through may occur. And also it's already in procedure, it said it must be done in two process. Yeah? So from A, B, C here, the best goes to D because it said no, the SAW welding process can be used on open root joint welded from one side only because of the problem with burn through. Yeah. All right, the problem with burn through. Yeah. All right, number 4. When considering distortion, which of the following butt weld preparation would be most suited for longitudinal weld main barrel joint? If we compare single and double, of course, double is the best in order controlling the distortion. Yeah. But if we have W, if we have, let's say, that W and single U, again, double is always the best. Single V, double V always the best controlling distortion. Okay? Number 5, fabricator proposed to you that he wished to reduce bevel angle from 45 to 30 on the set on nozzle. Which of the following issue may occur if it was permitted? So remember the problems here, the set on nozzle. All right, we have bevel in nozzle. All right, we have shell. Okay, then we have nozzle. So what happened if we reducing this? The angle here, let's say that they put 30 degree. Because of here, the gap or the bevel is too small, then manipulations of electrode may be a problem here. All right, because opening is too small, then we have problem with manipulations of electrode. Then that will cause lack of fusion problem here, right? But again, if you want to check from the spec, you may refer to 4.2, but B is the best answer here. Okay? Number 6, which distortion technique is referred to TWI spec? All right, look at 4.4 of the spec. Section 4.4. You said here, assembly for welding. To minimize strength distortion, it may be necessary to preset joint prior to welding or to specify the welding sequence to assist in control stress distortion, example, back step or back skip. Here, back step or back skip. So here the answer goes to C. All right, so back step is something like this. So we have a plate example, right? That is a joint. So what happened? They start from here, weld to back, skip one portion, weld here, back. All right, skip one portion, weld, the weld again here and back, and then come back, weld, right, weld there, and then weld. So that's, they call it back skip. The back step is almost the same, but there is no skip, all right? They continuously. 7, in accordance with TWI spec, would it be permissible to hard stamp the vessel material for purpose of material identification? All right, is it okay or not? Then check in the section 9.3 of the spec. All right, material marking. All marking shall be stenciled with suitable marker or low stress concentration dye on both ends of each item. They allow, but they say use low stress concentration dye. So that will give us the answer of C. Yes, hard stamping permitted, providing produce a low stress. In this case, normally they ask for having the kind of like a punch material for identification, which is rounded here. It must be round. So they're not allowed to use like a center punch like that, right? Which is very sharp edge here. So as a result, it will create unnecessary notch, and then fatigue failure can occur. So that's the problem here. So they're not allowed the use of this. Okay? All right, question 8. During fit up, you notice the longitudinal seam have different angle on one joint, top 50 degree and bottom bevel 15. So this will give us an idea that that bevel 50 top and 15 bottom, that is under position PC. But now the question asks, is it okay to have it in PA positions? That's the question asked. All right, look at 4.2. Bevel. So welded bevel shall be beveled to dimensions specified in the approved procedure. In the case of manual welding, PAPB and so on, 30 plus 5. All right. PC position, they ask for 15 plus 5 for bottom and top bevel 45 plus 5. So these 45 plus 5 or 50 and 15 here only apply for PC position. So they're not referring this to PA position. PA position only allowed in 30 plus 5. So that will give us the answer of C. Yeah? It's not mentioned in the spec. Right? 9, while inspecting completed vessel, you notice some longitudinal seam in the main barrel section in line with each other, which is not offset. So they're talking about we have a pipe, through pipe. All right, so what happened? We have circumference weldment like this, but we have longitudinal seam or well, which is in line. So this is in line. So this is longitudinal seam, all right? So it's supposed to be one side must be away from another side. So don't put it like this way. We produce very a weak area or joint here, okay? So look at page 11, 4.3. All right. 4.3 is very clear stated in the spec. In the case of longitudinal seam pipe or vessel, the longitudinal seam shall be offset by 90 degrees. Yeah. So that will give us the answer B. Yeah. All right, last questions. Fabricator wish to reduce welding time. So reducing welding time, we may refer to welding process like auto or semi-auto. Can be auto process, we can use SAW, or semi-auto or auto, or can be also auto in MIG, or we can use flux core. So that's reducing welding time. And controlling distortion here. Controlling distortion, the best always use double side. Double side. Double side here can be double V, or maybe we can use W. But again, if we compare double V and W, the best always W, better than double V, if we are talking about the best to control distortion. So in this case, this is MMA, it's not the best to reduce welding time. SAW, yes, but comparing this double V and W is better. Yeah, and then with SAW, so that's where the best answer goes to C. Yeah, all right.